as in 15 seconds from now. Fantastic. Hello, everybody. Welcome to our very first talk of the term with the Warwick AI Society. We've got a very exciting talk here. We have Kevin Donkers, who works with the Met Office as a research technologist and is also studying a PhD in environmental intelligence at the University of Exeter. The talk today is titled Environmental Intelligence, Data, AI, and Environmental Challenges. This will cover key issues that we see at the moment in the media, with climate change being a massive issue, but also we will see that there are a number of diverse issues that data and AI are able to tackle within this field. We will have a Q&A at the end. After a 45-minute talk, we'll have 15 minutes of Q&A, and there will be a giveaway to the best question that is asked from the chat in that time. So get thinking of them in YouTube Live during the talk, and I look forward to seeing what they are. Without further ado, it's time to hear from Kevin. We're very excited and very grateful that you're giving your talk today. Take it away for us, please, Kevin.
Thanks, James, and thanks very much for having me. It's an honor to be here. Let me present my screen. Grand. Excellent. Hello. So my name is Kevin Donkers. I work data science research team. I'm also a PhD student at the University of Exeter, doing a PhD in the Environmental Intelligence CDT. It's a Centre for Doctoral Training. And I'm also part of the Joint Centre for Excellence in Environmental Intelligence, which is a collaboration between the university and the Met Office, but I'll tell you more about that in the future. Okay, and this talks about, as James said, environmental intelligence, data, AI, and environmental challenges. So a bit about me. I did a master's in chemical physics at the University of Glasgow. Well, finished about 6 years ago now. I did a variety of research things before joining the Met Office. About 4 years ago, I joined as a software developer, doing developing data science tools, and I've been in the Informatics Lab for 2.5 years now. So this talk is going to sort of run through what environmental intelligence is. So starting off with sort of the challenges that set the scene, the opportunity that sort of comes out the back of that, our response, and our being the Joint Centre for Excellence in Environmental Intelligence and the Met Office, and then run through a few examples of the projects we've done in relation to environmental intelligence. Okay, so the challenge. First of all, there's climate change. The IPCC 6th assessment report came out this year, and we're pretty unequivocally, humans are influencing the climate. Limiting warming to 1.5 degrees is difficult, but still possible. And we're seeing a number of increasing extreme weather events, as well as shifting ecosystems around the world. It's fair to say that we can't ignore climate change anymore. It's definitely happening now, and we're on course for it to get worse. Action is needed now and going into the future, and pretty drastic action at that. In the midst of this, there's also an ecological crisis. Now, this is also known as biodiversity loss, sixth mass extinction, etc., etc. But essentially, the natural world is humans are influencing the natural world in a variety of ways, and a lot of them quite negative. We're losing a number of species at an increasing rate. We're losing wild habitats at an increasing rate. And this is starting to have an impact on our availability of pollinating insects to feed us, sort of quality of water, quality of air, etc., etc. This isn't just happening external to us, but it's becoming increasingly clear that this is affecting us in our day-to-day lives and our economies as well. And then the third aspect of this is human health. Air pollution is the fifth highest cause of health-related deaths in the world. Zoonotic viruses such as COVID-19 are becoming increasingly prevalent as a result of us sort of increasing to encroach into wild spaces. and thus increasing our contact with wild species, and thus increasing the chance for us to attain different diseases, as well as the impacts of climate change on our health, increasing extreme heat, increasing extreme cold in certain places. All of this is starting to impact us. So this sort of brings a sort of multifaceted challenge for our societies. We can't really treat these systems, which are sort of for the last 100 years have sort of philosophically been treated quite separate from us. It's becoming abundantly clear that ecosystems are affecting our economies are affecting ecosystems. Ecosystems are affecting our health. The climate is affecting our ability to produce food and ability to stay healthy. And being able to understand the interaction between these is increasingly important as it's clear that we need to look after our natural world as well as ourselves through looking after our natural world. So that's the challenge that is presented. What are the opportunities also happening in the world that might allow us to address these? So the first of this is an explosion in environmental data. So those who are familiar with the Cambrian explosion, this is sort of an analogy that is drawn to a number of times. But data generation is currently approaching the scale of tens of zettabytes of data per year. So that's tens of thousands, tens of trillions of gigabytes of data being produced every single year. Much of this is unstructured, which is a very juicy sort of machine learning problem. And from the environmental side, we get increasing amounts of data from remote sensing with the increase of satellites, sort of Earth observation satellites going into orbit. Cheap sensors like the Internet of Things is allowing us to monitor things like air quality like we never could before, and much cheaper. Numerical weather outputs are increasing in resolution and sort of quality as well. So for instance, climate model outputs and weather model outputs that we produce in the Met Office, but also flooding prediction and economic modeling as well. And then in particular, for some very interesting sources of data are these sort of proxies like mobile phones, using the time of flight of signals between cell phone towers to be able to understand sort of the moisture content in the air, or using these sort of passive beacons that that airplanes have to constantly sort of ping their location in the air. That is public usable data. We use this at the Met Office to infer the density of the atmosphere. Based on a plane's location and the receiver, we can infer things like air pressure and water content of the air along those trajectories, which we actually feed into our own weather forecasts. So there's an abundance of data there. There's an increasing abundance of data, particularly from inferring novel data sources. And this poses quite sort of an exciting opportunity, although it is very challenging because the volume of data itself is so difficult to deal with and sometimes access. Another opportunity is the availability of compute resources. So cloud computing has kind of revolutionized the availability of computers for people, and particularly people who wouldn't originally have access to those. Traditionally, like for instance at the Met Office, governments would have to sort of governments were the only organizations that could really stump up the cash to afford like entire buildings worth of computers. But with the likes of Amazon Web Services, Google Cloud, Microsoft Azure, DigitalOcean, other companies that is rent by the computers are. And to access computers that previously might have been very restricted to them. And allows ordinary sources that would with your own cache of data and run complex analyses like never before. This is a massive opportunity that is certainly revolutionised the development of new analytical techniques. Now, I've given a few examples here of machine learning and statistical modelling methods. Some of these aren't necessarily new, so some of them are, and some of them have been developed. Other ones are frankly very old, cheap, and lots of large-scale computers, and particularly parallel computing, as well as these huge volumes of data to frankly test and sort of inject into a lot of these statistical machine learning models. Use these techniques that were theorized decades ago and improve on them, which is sort of demonstrated lots of the newer techniques that have come along. And this allows us to sort of ingest these huge volumes of data that it would just be impossible to eyeball as a human. Sort of traditionally, I guess old style data science was simply to crunch some numbers and look at some visualizations, look at some graphs to try and infer some relationships from those. But if the data is on the scale of exabytes, you cannot do that, and therefore you need an automated computational system to churn through that in a sort of analytical way, to get to infer any sort of conclusions from those. But we can do that now with these new analytical techniques. It has certainly improved the ability of scientists at the Met Office to analyze data, but it's improved the ability for the likes of Netflix to recommend things to you, image analysis, and when it comes to environmental data, as we'll see later, able to sort of bring new analytical abilities that simply weren't there before, despite all the sort of all the decades of work and sort of millions of scientific hours that went into devising those models. Sometimes a machine learning method is the only way to get a sort of understanding from large data sets. Okay, so herein lies an opportunity sort of with this explosion of quality and quantity of environmental data from a variety of sources and an increasing variety of sources, along with the computational and analytical tools to analyze them. This is what we call environmental intelligence. This combination of environmental data, environmental challenges, and AI, essentially, that's where the intelligence part comes from. This is a very promising field. And this is where it leads to a sort of our response. And when I say our, I mean the Met Office, the University of Exeter, the joint centre between them, but in general also the scientific field. Sorry, I have to plug my laptop in. Generally, the scientific field is responding to this by trying to get together expertise to do this, because as I'm sure you will know, this stuff is impossible to do all by yourself. You have to bring together the people and skills needed to do that. So I work for the Met Office Informatics Lab. We're a data science, AI, and AI team, research team at the Met Office, specifically looking at the applications of data science in particular to weather and climate science. So the Met Office has forecast the weather in the UK, and most people know that, but a lot of people don't know that we're also one of the biggest climate science institutes through the Met Office Hadley Centre. So we've got about 500 scientists looking at weather and climate science as a sort of research, and that is their full-time job. And we're a team trying to bring the sort of expertise in cloud computing, expertise in data science and AI to address some of the scientific questions that those scientists have. We were quite a small agile team. We've actually grown quite big now, and we're about 6 years old. If you're interested at all coming to work for us, drop me an email at the end and I'll put you in contact with someone. We take internships all the time, and we're quite excited to work with different people. So if that sort of sounds interesting, let me know. A relatively new venture is the Joint Centre for Excellence in Environmental Intelligence. So this, as I've said, is between the Met Office and the University of Exeter. That's the main partnership of this, but what's also important is the sort of purpose of this joint centre is to develop partnerships, so foster partnerships with industry, other academic bodies, the public sector, to sort of champion environmental intelligence and all the potential wins that can be got from that. So that's been done through researching sort of at the interface of environmental and sustainability research, data science, artificial intelligence, and digital technologies, and sort of establishing the infrastructure and knowledge for that to be able to really underpin that capability, and then fostering the skills required in people to sort of do that environmental intelligence research and apply it to actual use cases. So some example projects of that are the sort of CLIMAR project, which I'll go through later. That's the Climate Change Impact Adaptation and Resilience project. So that's sort of a probabilistic framework, a mathematical framework used to assess risk of climate change. There's some work, the Pangeo is another example of the sort of infrastructure work. So that's an open source big data platform, geoscience platform that's made up of a bunch of open source technologies, and that's essentially bringing together the capabilities needed to cheaply allow researchers to sort of run their own scalable platform on the cloud. We're working with sort of different data sources and working with them at different scales. And then we're working with the Alan Turing Institute on climate change and food security, looking at integrating sort of different data sets into modeling disease, crop diseases as the climate changes. Something else that might be of interest to you is the Center for Doctoral Training in Environmental Intelligence. So this is the doctoral training program that I'm part of in my PhD. I've just finished my first year of that. So this is trying to bring together data science and AI, environmental challenges, and then crucially the sort of data governance, ethics, and social impact. So that's this data and context bubble. And that's trying to sort of develop into train doctoral level sort of researchers with quite interdisciplinary training, and particularly focusing on making sure that not only do we develop technical skills and sort of apply them to an environmental problem, but we do so ethically, we do so with consideration for the political and social context, and that we're sort of quite well-rounded in that respect. It's a 4-year program, so you go through 1 year of training, and then another 3 years of your actual PhD research. And by the end of that first year, you go through the process of basically devising. So you create your own research proposal. I've just been doing this. It's very hard, but it's very rewarding because you kind of create your own research and then finding your own supervisory team. It's not the case that they propose a research topic for you and they give you a supervisor. It's kind of the other way around. And this is what that training looks like. So you get some data science, sort of upskill various people in sort of data science skills and knowledge about environmental challenges, but also the skills required to consider the ethical implications of that. And that training continues right through through the 4 years, as well as having opportunities to go on placements and engage in grand challenges, which is essentially data hackathons with various industrial partners. And sometimes not sort of industrial partners is the wrong word. Partners, that can include sort of charities, other academic bodies, but also industrial partners. The last one we did was with a bunch of financial companies looking to assess the environmental credentials of their portfolios. So if you're interested in this, please let me know. Just fire me an email at the end. There's also a link to the website at the end of this talk. Okay, so I'm going to run through a couple of examples of projects that we do in the Joint Centre or we've done in the Informatics Lab. The first of this is CLIMAR. So this is the Climate Change Impact, Adaptation and Resilience. So this is a Joint Centre, sort of the flagship first Joint Centre project. It's a framework for expressing the risk of climate-related impacts. So whether this be increased risk of flooding, increased impact of urban heat, or the impact of changing weather patterns to renewable energy generation, climate change is going to have a very strange and non-linear impacts on our economy. And this framework, mathematical framework, is trying to factor in various data sources to try and understand the impact and particularly the uncertainty in the impact on certain parts of the economy, factoring in data from different scales and different sort of sources, how that data is biased, and then, as I said, the uncertainties of those as they cascade through this framework. Conceptually, it's built off the IPCC disaster risk, sort of, I don't know what to call this, trifecta, that in order to assess the risk of something happening, and particularly the risk of an impact of, say, an extreme weather event, you need to understand sort of what the hazard is. So that's going to be, in the case of urban heat, how much excess heat there is, or how much, how many days of the temperature reaches or exceeds certain thresholds, or the amount of rainfall in a place. That's the hazard. The exposure is how exposed people are to this. So this can involve where they live, what occupation they have, so on and so forth. And then vulnerability is how vulnerable people are to being affected by that hazard when they are exposed to it. So that can be, for instance, any underlying health effects, their age, and their gender, and so on and so forth. So in the case, so there's of this flagship project, we worked with Bristol City Council trying to understand the effects of climate change on urban heat. So as you may know, cities are particularly vulnerable to increased temperatures because of the urban heat island effect. That's the fact that because cities are made up of such hard surfaces and different materials, and are generally have low vegetation, they tend to heat up more so than the surrounding countryside. And as a result, that can have potential to a very high impact on people's health, particularly during the summer and during heat waves. So in this case, we've taken the UK climate projection, the latest UK climate projection data set from the Met Office Hadley Centre. So this is predicting the essentially daily weather forecasts right out until till 2080. Sorry. With various sort of climatic, atmospheric variables, including temperature. The exposure, we've got data from Bristol about the building characteristics and how much sort of ventilation those different buildings have, to try and assess how different parts of the city might be affected in the event of a heat wave. And then we've got some demographic data such as age and health status of various people within the city, to try and understand which areas are likely to be hotspots for health-related heat issues in the events of future heat waves, depending as the heat waves get longer and more intense, which is the information we get from the climate projections. There we go. So the latest prototype, we were working with Bristol City Council. They want sort of a visual tool to be able to interpret this information that we're building inside the framework. And the latest one here sort of factors in, I won't be able to put up a laser pointer, unfortunately. But here we've got a map of the different areas that are likely to be affected in the case of a 4 degree global warming world. If the population were to say at 2019 population. And here, not only do we get a map, but we also get some sort of probability density functions telling us how not only that the sort of the mean likely excess deaths that are likely to occur, but also the spread of that. And this uncertainty comes from, in particular, the uncertainties in the climate projections, but also uncertainties in population and demographic change, as well as the proportion of the each area that has sort of given underlying health conditions, so on and so forth. Okay, so that was an example of applying sort of statistical methods to try and understand, trying to communicate to decision makers the impacts of climate change. Now we're going to look at a rather different use case using deep Gaussian processing. Sorry, not deep Gaussian processing. Using deep learning to better predict rainfall in the UK. So this is what we call precipitation nowcasting. This has just been published, this project's just finished, but this was a collaboration between the Informatics Lab, the University of Exeter, and Google DeepMind. And this was quite a really good example of sort of public, academic, private collaboration to sort of improve techniques that are genuinely needed within the weather forecasting realm. So sort of to explain the problem, we, in the UK in particular, but generally, the best way to detect rainfall in the atmosphere is to use radar systems. So essentially, we have exactly the same thing detecting planes and ships. Will also bounce off rain clouds, and particularly raindrops within those rain clouds. The Met Office runs an observation network of radar stations around the UK, and that data we essentially download from those radar stations every 5 minutes. That tells us what the rain is doing every 5 minutes, and that's what we call observations. So that's us basically tracking what the atmosphere is doing every 5 minutes of the day. With that information, we essentially inject that information into our weather forecasting models, doing something called data assimilation. So because a weather forecast simulation doesn't instantly run, but actually takes several hours to run, the conditions that the observations that you put into initialize that weather forecasting model are not necessarily still valid as that model is running. So we get updated observations as we are running that very expensive weather forecasting model. So what we do is inject it using data, inject these new observations as they come along into the model as it's running, but that introduces what's called what can be colloquially called a statistical shock to the model, because there might be quite a difference in the new observed values that we've taken from the observations with what the weather forecast was currently predicting. And because we want everything in the model to be smooth, we do some very, very complex, and I do not understand it, but some very, very complex statistics to assimilate that such that you reduce the error between the new observations and the state of the model at the time that you injected the observations. But that means that the reliability of the forecast for the next 2 hours in the simulation world is actually a lot more unreliable than the weather forecast after those 2 hours. And it changes depending on the situation. Sometimes it's only unreliable for the next 30 minutes. Sometimes it's unreliable for the next 2 hours. But essentially, that's the sort of shock kind of has to sort of dissipate and ripple through the model before you get some reliable predictions out of the model again. This then presents a problem in that our weather forecasting models are not very good at predicting, particularly precipitation, particularly rainfall, for the next sort of 10 minutes to 2 hours. And that's the sort of problem situation that we were trying to solve with this collaboration. So essentially what is being done here, and I can share a link. I haven't put a link on these slides, but I will share a link to the paper afterwards. Essentially what's being done here is a generative model is producing plausible, a generative machine learning model is being given sort of radar observations. So what is currently happening now at time, essentially what we call time zero. So at the very start of the model running, this is what the rainfall looks like. And then we use a generator to try and generate plausible next images for the radar for the precipitation, including some information such as the orography, so the elevation of the ground underneath, which is very very predictive of what the rainfall is likely to do in the future. And a discriminator will then try and discriminate between the generated image and the original image, or more specifically, the next time step of the image. And it'll go round and round and round, iterating through until the generator starts to produce actually plausible looking rainfall for the next sort of 5 minute time steps, and then the next 10 minute, and then the next 15 minute, and that iterates and trains round and round and round until you get some very convincing looking generated images for the next sort of 5, 10, 15, 20 minutes into the future of that rainfall. Now, this essentially was assessed. This discriminator essentially assessed the same sort of spatial statistics to compare these sort of images, that is used through, elsewhere in sort of meteorological analysis. But what was cool about this project is they also used expert weather forecasters in sort of a what do we use? Sort of an interview setting or survey setting, where they had to pick themselves what out of these images between the sort of the two previously used nowcasting processes and this new sort of deep learning version, which is the image that they would rather use in their forecasting. So which method makes the most useful looking bit of data, even though all of them are just generating data, none of this data is real. What would be most useful for them as forecasters? And it was found sort of unequivocally, this new technique was producing very plausible looking and very useful sort of predictions of what the weather, what the rainfall is going to do in the next sort of 10, 20, 50, 30 minutes. And so this was published in September this year. And you see there's a lot of names on there because it was quite a broad collaboration. And if anyone's interested in reading the paper, I'm happy to share a link. But it was quite a sort of a success of a couple of years of work and collaborating with organizations outside of the Met Office. So that's my sort of whirlwind tour of environmental intelligence. There's lots more examples, and it's definitely an emerging field. The Joint Centre is very new, and it's something we're trying to champion, but it's something that's becoming something increasingly important to address some of the larger issues in our world. If you're interested at all, I'm very happy to answer your questions. There's some links there to the Met Office website to learn more about the Informatics Lab, the Joint Centre, the CDT I'm doing my PhD with. Extra Green Futures is a good website to look at various other sort of master's level degrees that are involved with this kind of work. And if you want to send me an email, feel free to use that email address there if you have any questions. Thank you very much.
Thank you very much, Kevin. We will now be moving on to questions, so please feel free in the YouTube chat to send any and all questions that you have in. For now, I'll just start us off with one of my own. What I particularly enjoyed was your example with the Bristol City Council and your work there, because I lived there when not in term time. So I was wondering mainly about when it comes to using the data as well, do you then go ahead once you have the data of which areas are going to be affected the most? Is there any kind of further analysis that you do potentially, kind of seeing if there are correlations with perhaps age or income of people in the area as well?
That's a good question. That's not what we have been doing. What we've been interested, we've not quite. What I described as kind of the limit of what we were doing with that project, because what we were keen to do was engage with Bristol City Council for them to try different scenarios to then ask those questions themselves, essentially. So it was about providing a tool that allowed them the information to try and assess those themselves, because we were less in a position to be able to understand the nuances or the implications of such impact. So we're trying to make it as sort of clear and as usable for them to make those decisions and analyses themselves, essentially. But it's a good question. We could have taken that data and done something with it, but I don't think we did, because that was kind of we'd achieve what we tried to achieve.
When working with government organisations, further to that, do you find that still there's any sort of kind of, I can't think of a better word particularly at the moment than prejudice towards data science, or people still thinking that it's quite different? Obviously, this will be a bit different because you're working with the Met Office, but I suppose the Met Office itself, I think there's some technicality that it's funded by the government, but not completely dictated by the government.
Yes.
So I was wondering if you think, if you could talk about dealing with government organizations, and perhaps whether you think you guys are more free to deal with AI technologies than perhaps more like tightly funded government organizations, or ones with, I don't know, more bureaucracy involved, for want of a better word.
That's a very, very good question, and I need to watch what I say. Only because of my own experience of working inside an organization like the Met Office. And the Met Office is wonderful. Like if anybody wants to come work for the Met Office, it is a wonderful organization, but it suffers from the same. It suffers from similar to other similarly sized organizations. So it's about 2,000 people. We are we have to keep the lights on. We have to deliver weather forecasts multiple times a day, every single day. If we don't for 18 hours, half the world's planes can't fly. So there's a restriction there that we are an operational organization. So we have to keep going. And as a result, there's an element of, there could be a lack of appetite for risk at times. So that's where the need for the informatics lab came along, is to be sort of the kind of a different, sort of almost not quite the opposite, but be deliberately agile, deliberately have a high risk appetite to try things, break things, test things out. And as a result, that we've been able to feed things like adoption of cloud computing and increased use of data, of machine learning and AI. And that's not to say that machine learning and AI wasn't in the Met Office before. And it might, there are some instances of where it was used, but nobody really called it that. But broader adoption of these techniques where they are seen to be applicable. And there was certainly an interesting. There were some cynical opinions towards data science and machine learning, because they're like, oh, we do that anyway, it's nothing special. But after some time sort of socially and creating that community around that sort of starting to develop a life of its own. And it's similar in other organizations, less so in academia. You see there's a bit more risk appetite there. But I think it's only as a result of the likes of the Informatics Lab and now the Joint Centre to really recognizing the need for those for that openness to new technologies, openness to new techniques within the public sector, that is maybe slightly more accepted in academia, though it's definitely not all public organizations. The likes of DSTL, the Defence Science Technology Lab, and GCHQ, they're very pro trying these things. They already recognize the need for sort of agile teams to go and try and break stuff. So it does depend on the organization itself. There isn't a one flavor of public sector, though at times there is also that sense of it depends what the kind of public body is. Is it trying to keep the lights on, in which case they're kind of a bit risk averse, or have they set aside a good amount of their workforce to try new things and develop things? It depends on the kind of organization you work for in the end.
Brilliant, thank you for that answer. One question from our audience now is, what's your image of the future in relation to the intersection of AI and climate? Given the amount of data available that could be exploited, it seems like AI is going to explode in terms of its use in fighting climate change. Is that correct?
Potentially, yes. I think the major hurdle to that is going to be the practicalities of accessing and using the data. If you find it hard to access climate data, it's almost entirely not because somebody's trying to stop you from getting to it, but because the practicalities of getting to it is fundamentally very hard, either because it's very big or it's on old systems. You can see this there is something called CMIP 5 and what's new CMIP 6. So that's the Climate Model Into Comparison project. That's essentially all the organizations in the world running climate models. They bring them all together and do a comparison between them. So understanding that different models have been set up in different ways, so that in places that they agree, we can understand that the uncertainty there is pretty small, given that completely different techniques have come to the same answer. But also where they completely differ, we understand that has more uncertainty around that aspect of the climate. This is on the scale of like hundreds of terabytes of data. You cannot download that to your computer, and frankly, you can't even download that to a cloud computer. It's on the scale that's far too big to access. And so then, that's not to say that machine learning can't help that, but this is where the likes of machine learning ops, ML ops, and DevOps, and the right infrastructure becomes very important, and it becomes a limiting factor. And this is part of what the Joint Centre is very keen to really champion, is okay, we've got all this data, we've got these cool techniques, but actually we don't have the underpinning technologies, or we do, but we haven't set up the underpinning technologies to allow people to simply ask questions, set up a couple of things, and get that running. Because at the moment, you have to do a hell of a lot of legwork. Sorry for my language. You have to do a lot of legwork yourself as a scientist, and you might not be well trained to set up that infrastructure to get there. It's getting better, but yeah, that's the major hurdle from my experience, is the infrastructure to get there. It's coming, and learning some of the skills to get there will help you if you want to start exploiting that. But yeah, it's a practical difficulty at this point.
Do you recommend any data sets on Kaggle or something like that, which may be a good way in for people if they want to play around with some environmental data themselves?
I'm sure there are. I don't know any off the top of my head. You can access, well, where can you access? You can access the UK climate projections, and they're not too big. Be wary that they are just one scenario. So don't take the answers you find with a pinch of salt. So there's on the CEDA website, CEDA, they have open access. They allow you open access, particularly as students, to the UK Climate Projections 18, which is the latest climate projections for the UK. And they go to fairly high resolution, but the scenario is RCP 8.5. So that's essentially the worst of the worst of the worst case scenario for emissions. And it's basically the hottest possible world we've modeled. So if you find some answers from that, get scared, but don't get too scared, because you've slightly picked kind of the worst case scenario. But yeah, CEDA is a place to go. It's slightly complex to access. Make sure you read the documentation. But that's a good place to start downloading some data sets and have a play around. I'm sure there are other ones as well. The USA has, through the likes of NASA and NCAR, they've also made some data sets available, but I'm afraid I can't remember what they're called. But yeah, have a Google around. There are some, but sometimes they're big, and maybe Kaggle is a good place to look, though I can tell you what to look for.
Brilliant, thank you. Another question is, in regards to the precipitation forecast project, how would that help tackle the issue of climate change?
It won't. So it's an example of applying these techniques to sort of the weather and climate field, or the weather field specifically. And what this will do will allow us to provide better predictions, particularly in the short term. And this is going to become particularly important when in adapting to the impacts of extreme weather. So if we're able to give shorter range forecasts, and essentially able to give warnings in short amounts of time, that's important given the nature of a lot of extreme precipitation events. So likes of flash flooding, that's the kind of stuff that doesn't show up in a regular weather forecasting model, but happens very quickly. So if we're able to predict that better, we're able to warn people better and deal with that. So that's very much a climate adaptation strategy, or a technique that's useful for climate adaptation, but it's not particularly useful for climate mitigation.
Brilliant, thank you. Another question that we've just got through is, has environmental intelligence research produced any results that will improve artificial intelligence as a whole?
Good question. It's quite young as a field, although it's essentially like with most fields, it's kind of where enough fields have overlapped for long enough that we go, oh, that's a new thing. So yes, I'm sure there are. I don't know any off the top of my head. I suppose I really should. In terms of the precipitation nowcasting work, I don't know how novel that technique was. Like with most deep learning, I'm sure almost every architecture of deep learning is in its own way kind of novel. But in terms of inventing a brand new technique, that wasn't the novelty in that research. It was more the application of it. They were able to get such a drastic improvement on previous techniques used for nowcasting that it essentially was generating very useful forecasts, short-term forecasts. But yeah, I'm afraid I don't know off the top of my head anything new. Keep an eye on the Informatics Lab blog, which I should probably keep that screen up. Keep an eye on the Informatics Lab blog. That's where we tend to share our a lot of the things that we develop and a lot of the things that we learn. But also, yeah, keep an eye on the Joint Centre website too. We'll announce it when we develop anything new.
Brilliant, thank you. Further to that, what advice would you have for someone who was, say, taking an undergraduate degree similar to yours in one of the sciences like chemistry or physics, when it comes to learning the statistics and mathematics behind some of these AI techniques?
Don't rely on your degree, because my degree didn't set me up particularly well. And these are still techniques that I'm learning, and I've kind of learned through osmosis through my job. So before I started this PhD, I've worked for 4 years or a bit more. I've been away from academia for 5 years before I started my PhD, which was slightly daunting. What university teaches you to do is how to learn stuff. And I know that's a very boring cliche, but it's kind of true. There's a lot of resources to go and learn these things. And particularly if you've done a physical science of some sort, as much as you might not have come across a lot of the mathematics that you need to learn, you will have developed an understanding of the use of mathematics, almost regardless of what science you've learned, to a level that will help you. And that might require you sort of to occasionally ask for help, people that you know, or to attend courses, to do that sort of outside of university sort of training. Because my physics degree surprisingly didn't really set me up very well for statistics at all. But I've since been able to learn them through sort of popular science reading, online courses on YouTube and Coursera and things like that. And then also through my PhD training, that's what there's people who came into this from social sciences, or even things like politics and literature. So we were a very interdisciplinary group. And as a result, some people literally had never done the maths in school. And it was very difficult for them to learn, but they could still learn it. So I guess don't be put off because it's not part of your degree. If you're still doing an undergraduate, maybe look at attending some of the statistics and mathematics courses and machine learning courses that are at university. You'd be surprised at what you can just sort of rock up to the back of a lecture theatre and observe a lecture. Even though it's not on your course, that's an option for a lot of people. So yeah, essentially there's a lot of learning out there. If you've been to uni or you're currently at uni, you are learning how to learn, and it's getting easier and easier these days to teach yourself. So that is a good way to do it, even if you don't feel that you've formally been trained in those techniques as part of your degree.
Brilliant, thank you. One last question from the chat as well is, with big tech having the majority of data collected throughout the world, do you think that this could lead to manipulation of the government since they have to rely on these companies later?
That might be a winner for the best question. That's a brilliant question. Yes, potentially, but probably less dystopian than you would think. Because of all the organizations with massive amounts of data, the government is itself one with a lot of the data. And yes, some of that's personal, but some of it's actually kind of quite benign. So things like through my PhD, I might be able to get access to all the data from the Rural Payments Agency. That tells me what every single field in the UK has been paid to do for the last 50 years by the government. Now that's not, I guess there's a level of sensitivity there. But that's a hugely valuable asset that currently hasn't been accessed. It's a bit like the question about climate data before, that yes, there's this data that's sort of being sat on and not being analysed. It's the same with historical weather data. There's a huge amount that sort of modern techniques could sort of trawl through and infer a lot of useful things from. With regards to private companies and the government, there is a genuine risk there that, as our government seems to currently be quite open to sharing data that the government currently holds exclusively with large tech companies on the expectation that they will innovate something wonderful and magical that will benefit everybody. there is a risk that they're being a bit too blasé with that. If you're interested in staying abreast of this, pay attention to the changes in GDPR that are currently being proposed to come. So GDPR protects our data a lot, and is a world-leading standard that we currently hold. There is talk about changes to that, which to some people set off alarm bells, and it's worth paying attention to. And in part, the reasoning behind that is to kind of liberalize access to data for entrepreneurial purposes. But that includes access for big companies, not just small companies and new companies in the UK. And the risk there is the likes of Google and Facebook hoover that data up and hold on to it themselves and just add it to their massive data ecosystem. It's not necessarily a given, but it's something worth paying attention to, and it's a field that's evolving. And to understand the political context for that and the evolution of that, I think would be important, regardless, particularly if you stay in any sort of data science job, or if you go into any data science job or any data science training. But even outside of it, just to stay abreast of it, it will have impacts, but it's not necessarily immediately negative ones, but it will have impacts, subtle and obvious. So kind of a watch this space is my best answer to that, because I don't really know what's going to happen as things change.
Brilliant. Thank you very much for that. And with that, we will wrap things up there. Thank you very much, everyone, for attending. But just before we finish, Kevin, could you select your best question, please?
I think it's got to be the government. The government data industry question. I think that was a very astute question to ask, and very timely. I'd say, yeah, keep an eye on that in the next few months.
Well, Jacob Coates, if you would like to message Warwick AI, we'll get you sorted out with your giveaway. Thank you everyone else who attended. Thank you everyone for asking questions as well. But most importantly, thank you very much, Kevin, for taking the time out to join us and give us this talk today.
Thank you very much for having me. It was a pleasure.